Letter E is a good reminder to make sure you simplify all trinomials before you're finished with your factoring. Okay, so you have to see trinomials, and not just obvious trinomials. Sometimes you have to see trinomials when they're not obvious. Let me show you what I mean. So I've written letter E out down below here, and notice that right now it doesn't look like there's anything I can do because the denominators are different. But wait a second, I see a trinomial here. Okay, this is the first trinomial in this problem, and it's an obvious one. It's obviously a trinomial. What are the factors of 6 that add up to 5? Well, that's just going to be 2 and 3, x plus 2, x plus 3. So this becomes x plus 2 times x plus 3 on the bottom. Now I can look at my two fractions, and I notice that in my first fraction, the bottom is missing a factor. It's missing x plus 2. If x plus 2 is multiplying x plus 3 over here, I could add them or subtract them. So in this case, all I need to do is put in an x plus 2. I'm going to install that right before the x plus 3. Let's just do that. Okay, x plus 2. But in order to multiply the bottom by x plus 2, I also have to multiply the top times x plus 2. So we're going to put an x plus 2 up here as well. We'll maybe be able to make this a respectable fraction bar now. And there we go. Okay, so now I can add these. Actually, and I keep saying add, but really it's subtracting them because there's a minus sign between. So what I'm going to be left with when I do this math is x plus 2 minus 3 over x plus 2 times x plus 3 in my denominator. Now, there is absolutely nothing that I can cancel out of this. It looks like I might be able to cancel an x plus 2 because it's in the numerator and the denominator, but unless it's in every term in the numerator, or unless it's just one of the only factors in the numerator, there's nothing I can do with it. I can't divide it because it's not also multiplying the negative 3. But wait, I spy with my little eye a trinomial on the top of this fraction. Now, this one doesn't look like an obvious trinomial, but it is, because I can multiply x times x plus 2, and I'm going to get a trinomial. Okay, so let's do that. The benefit of doing that is when I get a trinomial, if I can factor it, a trinomial turns into just 2 multiplied factors. Right now, the problem is that I don't have 2 multiplied factors on top. I have one set of multiplied factors and then just this constant over here. So this is going to become x squared plus 2x minus 3. X squared plus 2x minus 3. Okay? Now, are there factors of negative 3 that add up to positive 2? Negative 1 and positive 3. Negative 1 and 3. So on top here, this becomes x minus 1, x plus 3. And now I can cancel. I can cancel the x plus 3 because it's multiplied by what's on top. So let's go ahead and cross this off. Let's go ahead and cross. Let's see. I can maybe move that up. There we go. And then we're just going to do the same thing for the x minus 3 on the top. I should be left with x minus 1 over x plus 2. And the trick to that was seeing that I had a trinomial on the top if I multiplied everything out. Let's make sure we got that one right. There it is. All right, on to letter F. See how these are getting gradually more difficult, okay? There's more steps and more things that you have to see. All right, let's see what this one has in store for us. Negative 1. So it's going to be negative 1 over t to the 4th minus 2. Now, when I see a t to the 4th, my initial thought is, oh, I wonder if this one can be is a special product, like a difference of 2 squares. It's only a difference of 2 squares, though, if the second number is a square too. 2 is not a perfect square, so there's nothing I can do with that one on the bottom. So this is going to be negative 1 over t to the 4th minus 2 plus, okay, so there's a plus sign in between. That's good to know. Let's see if we can get rid of all these extra spaces here. Plus, and then on the other side, we have t plus 9 over 2 minus t to the 4th. Okay, I see what's going on here. This is a special kind of problem. Now, if you ever run into a problem like this, notice the only thing making the denominators different is that the signs in the terms are different. Notice this one is positive t to the fourth minus 2. This is negative t to the fourth plus 2 if I switch the order. What can I do about that if the signs are different? Well, here's what I can do. I can add two negatives into my problem. I have to add two negatives because if I just add one negative, I'm changing it. But a negative becomes a positive again. A negative undoes the other negative. What I'm going to do here is I'm going to put t plus 9 on top in parentheses. T plus 9. Okay. And then I'm going to put a negative out front of that. So it's negative t plus 9. And then the bottom, I'm going to put 2 minus t to the fourth in parentheses. And we're going to put a negative out in front of that too. Okay, now how did that help? Let's distribute the negative on the bottom. I'm going to leave the negative on the top. Let's distribute the negative on the bottom. This becomes, when I multiply this negative 2 plus t to the fourth, negative 2 plus t to the fourth, which is the same as t to the fourth minus 2. Okay, so this on the bottom becomes t to the fourth minus 2 because I put that negative on top. Now let's just take care of this negative on top right away. I'm going to distribute this into the parentheses too. So it's actually going to be negative t minus 9 on top. And now I have common denominators. I can actually add these fractions. This becomes, on top, negative 1 plus t minus 9. When I add that all together, it becomes t minus 10 on top. And then on the bottom, I have t to the fourth minus 2 over t to the fourth minus 2. Now, as I look at this, there's not a trinomial on the bottom, and it's not a difference of two squares. There's nothing I can do to factor this more. I can't factor anything out of the top. There's nothing else I could factor out of the bottom. The real trick to this one was being able to add them by making the sign of this correct. Let's just make sure we did this one right. T minus 10 over t to the fourth minus 2. All right, and then letter G. A kayaker paddles 5 miles one way against the current and then makes the return trip with the current. Write and simplify an expression for the total time of the kayaking trip, assuming the rate of the current remains constant and that the kayaker's paddling averages 1.5 miles per hour. Okay, now the thing about this problem is it's a certain type of problem that's always worked the same way. So pay attention to the method by which I work this, because whenever you run into a problem like this in the future, it's going to be set up exactly the same. And one of the things you need to know is we have a formula for distance that's going to come into play here. Distance equals rate times time. This is a formula that in Saxon math comes up time and time again, and in real life, honestly, comes up time and time again. So it's a good equation to know. Distance equals rate times time. Well, wait a second. If distance equals rate times time, what is time? Time equals rate over, distance over the rate. Distance divided by the rate. Because what we're looking for is for the total time in the kayaking trip. Now, there's a certain amount of time it's going to take to go against the current, 5 miles, and then with the current, 5 miles. So here's how this is going to look. The amount of time is always going to be distance over rate. We know that the distance is 5 miles both ways. So 5 miles divided by the rate. Well, what is the rate at which we're traveling? Okay, let's think about this for a second. The rate is going to be, let's see, the kayaker average paddling is 1.5 miles per hour. 1.5 when we're going with the current, but the current is actually adding more speed for the first 5 miles. Oh, no, I'm sorry. It's subtracting speed for the first 5 miles. So it's going to be 1.5 minus the speed of the current on the way there. Okay, so my first trip is 5 over 1.5 minus c. And then we're going to say that we're going to add to that. The way back is going to be 5 miles divided by the rate back. How fast is the rate on the way back? Well, on the way back, it's going to be 1.5 plus c. Now, is there a way for me to combine these? I need to take this first, to get a common denominator, I need to make sure that I have both factors, 1.5 minus c and 1.5 plus c in the denominator. So what I'm going to do is I'm going to put a 1.5 plus c in the first denominator. In order to multiply the bottom by 1.5 plus c, I have to multiply the top by 1.5 plus c. So let me get that. 5 times 1.5 plus c. Okay. Now I'm going to add to that the second fraction, and I'm going to do the same sort of thing. In the denominator, I have 1.5 plus c. I'm going with the current in the second fraction. I need to multiply that by 1.5 minus c. But in order to multiply by 1.5 minus c on the bottom, I also have to multiply by 1.5 minus c on the top. And this is going to be my expression. Now I can actually do the addition on the top. So the way that this is going to look when I rewrite this fraction, it's going to be 5 times 1.5. Well, hold on. Maybe I should just distribute this on top right away and then add what I can actually add. On top, 5 times 1.5 is 7.5. So this is going to be 7.5 plus 5c plus, on this side, 5 times 1.5 is 7.5 minus 5c when I distribute this one, okay? Notice a plus 5c and a minus 5c. Those are going to cancel each other out in this problem. On my denominator, I'm just going to have the same thing. 1.5 minus c, 1.5 plus c. Now, if I wanted to multiply those together, that's going to be the difference of two squares. So it's going to be c squared. Actually, it would be 1.5 squared minus c squared. I'm not going to worry about multiplying those out, though, because usually we leave things in factor form. But I do need to combine in the numerator. 5c minus 5c is going to get rid of the c term, and then I'm left with 7.5 plus 7.5. So I get 15 in the numerator, and that is my fraction. 15 over 1.5 minus c times 1.5 plus c. There we go. That was sort of a specialized type of problem. It's going to come up again, and you're always going to work them essentially the same way, with the current against the current, and then make sure you get a common denominator. That is how you work those types of problems. You are now ready to do the problem set for next time.